Now, you may be wondering, okay, so why did it print this variable value out? Well, if you just call a variable without anything, without assigning it or without calling a function on it, it prints the variable verbatim in Jupyter. This doesn't work in other IDEs or, well, it will work in the Python interpreter, but it won't work in IDEs, but it does work in Jupyter. And so you may be wondering, okay, so why do we need to store it in a variable? Well, in a variable, we can actually do several cool things, such as, for example, the repeated addition to a single variable. So say, for example, we have weight kilograms equals 60. If you write a function that says, I want to continue to add 1 to this variable, you don't need to know for loops for now, but let's just say that we're adding the number 1 to weight kilograms 5 times. So for I in range of 5, weight kilograms equals weight kilograms plus 1. So we're just continuously adding 1 to weight kilograms and weight kilograms. And now it's 65. Note that if we did something like this, times 4 plus 1, it wouldn't actually work at all. 3 plus 5 times 4 plus 1. And that's because we're not actually storing the variable, or we're not storing this value in the variable in the first place. So why it's printing out, oh yeah, it's printing out this. We should be doing 60 rather than 20, or rather than 24. So if we do something like this, it'll only print 61, and that's because this variable is going away, and so it won't actually continue to add 1 to weight kilograms. It's adding 1 to whatever original value we set weight kilograms at, and so it prints 61. So that's a pretty simple means as to why we'd want to store values within variables. It allows us to save them and then continue to do arithmetic to these variables. So in the print command, as you can see, we can output particular values. Our value for weight kilograms right now is 61, because it hasn't forgotten that yet. And we can print multiple things within one print command by separating it. So if I wanted to say weight in kilograms and the weight kilograms, as you can see, I have a string that says weight in kilograms, comma, weight kilograms. You don't need to worry about not knowing what a string is yet, but essentially these are different ways to call a print function to output your whatever valuable or whatever output you'd like. So as I've said before, if we wanted to change the value of weight kilograms, we can assign it a new variable, or we can just continue to set weight kilograms and then do some arithmetic on weight kilograms. So if I print weight kilograms right now, it's 66, and if I continue to run this cell, it will continue to add 5 to the weight kilograms variable. Now, one of the biggest things about Jupyter Notebook that may not be important for Python, but is important for Jupyter, is that things can be run out of order. So for example, here we have weight in kilograms is now 76. When we print this out, this is a code block before this code block. If you print this out, it will print 76. I could go all the way to the start, and if I delete this, for example, this is now also 76. So one thing to keep in mind is that Jupyter Notebook code cells can be run out of order, and it may cause a lot of confusion for people, especially if you're not putting all of your code in one code block. This is not a problem in other IDEs, but it is something you need to be cognizant about in Jupyter. So now if I print this out, this should print 65. So as we see here, we're doing more just simple arithmetic. If you wanted to convert weight kilograms to weight pounds, we can go ahead and just do a simple estimation using 2.2 times weight kilograms. When we print this out, we can see that the weight in kilograms is 65, and in pounds, the weight is 143. As you can see, we're using an F string in which we're able to put variables between curly braces and then put these variables within the string so they print out in this fashion. We can go ahead and change weight kilogram to a different value, but note that even if weight kilograms have changed, you didn't actually update weight pounds, and therefore weight pounds is still 143, even though 143 pounds doesn't correspond to 100 kilograms. So make sure to keep that in mind, as you know, when you choose one or when you change one variable, it doesn't necessarily change the value of another variable, even though it may or may not be intuitive to you. So I've pretty much glossed over how to output like arithmetic as well as variables. Now let's get into the overview of basic data types. Now, Python has a lot of various data types, just like most other programming languages. But what's important to note is that, especially if you know programming, Python doesn't have static typing. Python has dynamic typing, and therefore its type declaration or typing of variables is done through runtime, not in compile time. So there's no such thing as in kilograms equals 60. And then there's also no such thing as just weight kilogram, which may be synonymous to int weight kilogram. This does not exist in Python. How Python determines typing in variables is assignment. So if we go back all the way to the start, because weight kilograms is being assigned a float, when you print the type of weight kilograms, it's a float. If I delete these decimals, then it's an integer. And if I put a string, it then becomes a string. So let's go ahead and go back to the start. Integer numbers, as you saw, are just any discrete variable or any discrete number, no decimal point. So once you add a decimal point, it becomes a float or a floating point. And strings are not numbers, but they're essentially words within a programming language. And so you can have numbers in them. You can say, hello, my value is 60. And this is a string. You can print the string. And it prints that out. What's important to note is that weight kilograms now is, because there is no static typing, it may not be always obvious what the type of this variable is. I could say int weight kilograms, but that doesn't make any sense because now this is a string, even though I named it an int, or I changed the name to an int. And so it may not be obvious to other programmers what the typing of this variable is because there is no int keyword in front of it or string keyword in front of it. So let's just change that back. As you can see in Python, we can change or we can check the variable type using the type function. So it works a lot like the print function, where essentially if you want to know the type of a variable, you call the type function, parentheses, the variable, and then parentheses. As you can see, we have an integer, a float, as well as complex variables, which is not something that you normally see in other programming languages. But yes, you can define a complex number in Python. To use strings in Python, you either have to use single quotes or double quotes. Normally, in other programming languages, single quote denotes a character object. But in Python, this is not the case. In Python, you can use both single quotes and double quotes for strings. There's no such thing as a character in Python necessarily. So you basically have both to your disposal when creating strings. As you can see, we're printing statement, and statement is an F string with single quotes. If we delete this F, suddenly it prints my whole name is first name, last name. But if we add this F, then it prints the variables within the curly braces. So there you go. That's that working. Now, strings have several methods available to them, which these are kind of more like creature comfort functions. So as you can see, we can make a whole string lowercase or uppercase. We can also replace parts of the string with another string. So for example, here we're replacing Bob Builder to Branda. So now it says my whole name is Brand the Builder instead of Bob Builder. One of the things in Python, thanks to the fact that you have single and double quotes, is the fact that you can use single quotes in double quote strings, or you can use double quotes in single quote string. So for example, here, we're able to use a single quotes within the double quote string, and you can do this vice versa. You can put single quotes out here and then double quotes in here. Alternatively, if you really need to use single quotes, Python still has string escape, and so you can go ahead and click type backslash and then the character such as single quotes to escape, and then another backslash and single quotes, and you're able to put single quote characters in a single quote string. Note that, for example, if you delete these, Python now gets confused because it thinks, okay, this is the end of the string. Here's one single quote. Here's another single quote. Thinks this is a variable now, and that this is another but empty string. So you would need the escape keys, or to replace your string instantiation like symbols to double quotes, to use single quotes. That's all very helpful and all, but one of the biggest concepts within programming is use of containers and arrays to store multiple variables. So in Python, lists are very flexible. They can contain numbers, strings, methods, and they can contain several different types within the list. So if I had a numbers list, for example, and I printed numbers list, as you can see, I have this numbers list. However, a list can have all sorts of objects within it. I could say my list equals 8, 8.0, DAX, and what. And if I print my list, as you can see, I just stored a ton of different data types within my list, which, unless you were using something like a t-object, isn't really intuitive to do in other programming languages, especially when you need to do something like this for your variable. And then now you can only store integers within this list variable. If I want to call it list, then here we go. So you can only store integers in this list variable, but here in Python, we can store an int, a float, and a string, and whatever else we would like to store within this list with no problems. Additionally, lists in Python are kind of like array lists, where you can go ahead and just append variables to your list. You don't have a fixed length or count, such as arrays in Java or C#. So as you can see from this numbers list up here, if we want to add 0 or the number 0 to this list, we can go ahead and call the append function to numbers list. And when we print numbers list out, we have 0 at the end. Sorting in Python is also very easy because Python has a sort method for numbers list, or for any list. Of course, the sorting is dependent on what variables are inside of the list, such as if you have strings and integers, or if you just have strings, etc. But as you can see here, we can just go ahead and call the sort function, and when we print out numbers list, it's sorted. Additionally, Python has a reverse list or a reverse function for lists. So if you wanted to, say, for example, sort a list in descending order, then you can just sort it and then call reverse, and now we have a descending order list. We can go ahead and remove a specific value within the list without knowing the index of it. And how this works is that the very first object that matches this case within this function will get removed. So as you can see here, numbers list.remove 7, it went through the list and removed our 7, even though we didn't know the index of where 7 was. And if you want to remove a value within a specific index, you can go ahead and just call the delete function on numbers list 1. And so when we do delete numbers list 1, we delete number 8. One of the biggest things about any programming language is that most actually start from an index of 0. Which is why there's a question here saying, why would an object at position 1 be the second item in the list? So let's go ahead and define numbers list again. We're going to run through all of this because, like I said, code can be run out of order. When we go ahead and look at, let's go ahead and comment this, and commenting in Jupyter is just control and /. Commenting means that this code is not interpretable. It won't be run, and you can add whatever jargon you want here, even if it doesn't make sense to the programming language. When we go ahead and print numbers list, we get this. And if we copy this, the positions of these are actually start at 0 for most lists in many programming languages. Or for most programming languages. So we can go ahead and think of this as 0, 1, 2, 3, 4, and 5. So 14 is at position 0, 8 is at position 1, 6 is at position 2, so on and so forth. And at position 5, we have -12. So when we call delete numbers list of 1, it's not deleting the first item, it's deleting the item at index 1. And because our indices start at 0, the 0th index is 14. And the first index is 8. So when we go ahead and call the delete numbers list at 1, this 8 goes away. If you want to, it's essentially a pop function if you know what programming is, or if you have prior programming experience. But if you want to delete a variable and then assign it to another variable, like let's say you want to go ahead and pop at the third index, which is -3, so 0, 1, 2, 3. If I want to pop at index 3 and set it to like my number, let's say it's my lucky number is -3. You can go ahead and type numberslist.pop, you pop the third index, and whatever this evaluates to, so this evaluates to -3, it gets assigned to my number. So that when we print this out, as you can see, my number is -3, and numbers list is 14, 6, 0, and 12, and -3 has gone away. Concatenating lists in Python is also really easy. You can go ahead and just add two lists together, and what it'll do is concatenate the second list to the first list. So as you can see here, if we concatenate numbers list to numbers list, we get two copies of the values within numbers list. You can then also insert variables at a specific place within list. So say, for example, if you want 29 to appear at index 1 in the list, you can go ahead and do numbers list insert 1 and then 29. So this is the position, this is the value. And once we do that, 29 now exists within index 1. Lastly, this is pretty normal stuff. If you want to set a value within the list, you just call the position operator from Python or within any programming language, and you do that using square brackets and then the position, and then you can assign the position a value. Now, what's pretty interesting is that, as you can see here, what the heck is index -2? And for most other programming languages, this is an index error because you can't really get a negative index. But in Python, negative values are actually indicative of values at the end of the list. So if we count the list from the end to the beginning, this is actually -4. This is -3. It's -2. Oops. This is -5. -4. -3. -2. And -1. So a little confusingly, when you go from the end of the list instead of the start of the list, it actually starts at -1. And that's because you can't have -0, which would result to 0. So it starts at -1, and -1 means the last item in the list. -2 means the second to the last item, so on and so forth. So even if you don't know the length of the list, you can still call values at the end of the list using the negative notation. And then, much like every other programming language, you also have a method to count the length of an iterable or a list object. So as you can see here, we're calling length on numbers list. And the output of this is 5. Here we have a different code block, and I'm not sure why this is in this code block, but you can also slice arrays using the colon operator within Python. So if I go ahead and just add another code block here, you can see that we're setting a variable slice list to be numbers list, and we can go ahead and slice whatever lists we have arbitrarily by using colon. So if I go from 1 to -1, for example, and we print out slice list, as you can see, our numbers list is 120, numbers list 2. We can see that our numbers list is 120, 29, 6, 125, and 120. When we slice a list, it looks similar to calling a variable at an index, but you have a starting position, colon, and then an ending position. So if I go ahead and do this, the starting position is 0, the ending position is the count of the list. So as you can see, we have the original list. But if we call from -1 or from 1 to nothing, then it takes out this first 120. If we go from 1 to, let's say, 3, then it takes out 120. It starts at index 1, and then it ends at index 3. So we now get 29 and 6. So you can go ahead and slice arrays that way instead of instantiating new arrays and then defining the variables manually. Tuples. Tuples in Python are like lists, except they're immutable, so you can't actually assign any of these variables to be different. For example, here we have a numbers tuple 14, 12, and 94. If you try to set a value in an already made tuple, it won't work. And as you can see, there's an error saying that tuple does not support item assignment. You can't assign values to any of the, or to the tuple itself, or any of the locations in the tuple. And so here we get a first look at what exceptions are. And it's essentially, exceptions are errors, and they cause your code to break, essentially. They're errors that disallow the code to continue running. And for here, we're given a type error. And our type error is that the tuple does not support item assignment. Exceptions can be particularly helpful because they usually come with line numbers, and through these line numbers, you can actually see where the code went wrong. So for us, it says that in line number 1 of this code block, we see that numbers tuple at 0 is equals to 4, and that's wrong. So I have a question. Is the list marked as a tuple, or list items cannot be replaced? So lists are mutable. So you can change items within a list. However, in tuples, actually, this is a very good point. Tuples are defined using parentheses instead, which can be a little confusing because you also use parentheses for functions, but essentially it's parentheses without a keyword in front of it, or without the function name in front of it. You can define tuples this way, which is unlike lists where you define it using square brackets instead. So in lists, you can change the variables, but in tuples, you cannot. Dictionaries. So dictionaries are like lists, except that they have keys and values. And so what's particularly interesting about keys and values is that you can actually, instead of saying information at 0, which isn't particularly helpful, you can call certain variables within this collection using keys instead. So say, for example, you wanted information name. As you can see here, it will return Bob Builder. This information list could be this information dictionary can be converted into a list simply by going ahead and changing this and deleting all of the, deleting all of the keys. So now we have an information list, Bob Builder 55 in male. And whilst to us, we know, okay, information at 0 is going to return Bob Builder, right? And information at 1 is going to return 55, and information at 2 is going to return male. Information at 0, 1, 2, and 3 is not intuitive, and it doesn't really make any sense to call it in that fashion, especially if you don't know which indices correspond to what. So dictionaries instead give you a more helpful way of accessing information within a collection by, instead of using list indices, you can use keys. So when you call information at name, it returns Bob Builder instead of having to say information at index 0. So as you can see here, we define a dictionary using curly braces. The first parameter is your key separated by a colon, separated by a colon, and then the value for that key. So the value for name is Bob Builder. Then you separate whole keys and values using comma. So at key name, the value is Bob Builder. At key age, the value is 55. At key gender, the value is male. So when we print this out, you can see Bob's name is Bob Builder, Bob's gender is male. So to add new keys to a dictionary is actually pretty simple. You, much like dynamic typing, you essentially just assign a key, a variable, so you have to do assignment. And then you're able to just create a new key with a value. Now, this is different, for example, to doing something like this. Let's go ahead and comment this out. And as you can see, this gives you a key error. The key distinction, so this is essentially the same as information trade plus construction. It's just the shorthand version. The difference is that here we're doing an operation, addition, or concatenation if this was a string, to information at trade. But as you can see from the information dictionary, there is no key trade, right? So we essentially, first of all, have to assign a value to trade so that trade as a key or as a key value pair will be created in the information dictionary. So here we go. And now when we do this operation, this will work just fine because now we're adding construction to the old trade value. So when we print out trade, as many of you may know, when we print this out, it'll be construction because we added construction to construction and it did a string concatenation. So here's an activity of where it says to add a new key to information which holds his hair color. And then you essentially write a print statement concerning Bob's age and hair color. Here we already did it for you. Information at hair color equals brown. And this works because we're assigning a value. We're not doing any operation. So it creates this key and assigns it this value. And then we can go ahead and print this out. You can use an F string. You can use string concatenation. Here we use string concatenation. So Bob age is plus the string. So this gets added to this string and his hair color. And we add it to the previous string and then information hair color, which is brown. And so when we print this out, it adds this string to this prior string, so on and so forth, and the entire string gets concatenated. Print statements, though, as you may know, you can replace plus with comma, and it'll print each of the statements sequentially given how many parameters there are. Additionally, you can use f strings. So you can do this, and then Bob's age is, do curly brackets to denote that you're trying to print out a code block, and then string information age, so it prints that as a code block, and his hair color is, and then another curly brace within the f string to denote that you're printing a code block, and then you can go ahead and just terminate this. And this works as well. As I've told you a while ago, you can also add comments to your code, and code comments essentially are lines of code that are ignored by the interpreter. So you can add anything to a code comment. So here's one example of an in-code comment. And obviously, if I delete this, it doesn't make sense programmatically, but because we are commenting it, it doesn't get run. There is also another way to do code comments, and it's through triple quote. And now using this, unlike the above example, this doesn't resume to the next line, but in triple quotes, you can add multi-line code comments, and this doesn't get run either. You can also have comments after code blocks. So as you can see here, we do some very simple arithmetic, and then the code comment follows after the code itself. Obviously, this doesn't work in the opposite way, as anything after the pound sign will be treated as a comment. So x equals 5 times 5 doesn't work here. And so this line is totally unaffected by these other comments. And additionally, why code comments can be very helpful is because you can say, for example, if code doesn't work, or if you want to just simply turn off a part of code, you can comment actual code line so that they don't actually do anything. So as you can see, we now print 125 because we assign y as x times 5, which is 25 times 5, and we print y. But if we comment this out, this code doesn't run anymore. May be helpful when you have errors. So that's the conclusion of basic types, as well as functions within these basic data types. Now, what's important in practically everything that is in regards to programming is actually building and using functions. This may not be important, or building functions may not be important, especially if functions within libraries exist. So say, for example, you use a library for data science, and your data science library has a bunch of statistical methods. Suddenly, you don't have to build, statistical methods such as Fahrenheit to Celsius. Maybe you have a conversion function inbuilt to the library that you're already using, and therefore it's not really pertinent for you to be able to build functions. But it's important to go ahead and at least have a thought process as to how functions work. So to build or to define functions, you essentially define, use the def keyword, and then your function name, and then your explicit parameters. So for here, we have define Fahrenheit to Celsius, and for our parameters, we want a temperature. In order to use this, then would be Fahrenheit to Celsius, oops. And you would put some kind of Fahrenheit values such as 80, And it says that Fahrenheit to Celsius of 80 is 26.66. For people who know programming, you may note that there is no declaration of what the return type is. Like you're not telling Python, okay, go return an int or go return a float. In addition, there is no such thing as a void function, because in order to make a void function or a function that doesn't return anything, you just delete the return statement, and Python doesn't care. It will just go and run this result, and then it will just work. But if you do give it a return, or if you use a return keyword in your function, then the return type is whatever type the result actually is. So for us, the type of this result is float. But if this resolved to an integer, then or if this was a clean division, for example, then the return type of this result would actually be an int. So the return types can very much just change arbitrarily. So how is the end of the function statement identified? It's essentially the last line of code within your function. So if you have a return statement, so let's say, for example, if, I don't know, if true, and you'll have this, else, just think of true as something else, and then you do return. So say, for example, you have this function. If it hits a return function, or if it hits a return keyword, it will go ahead and escape the function. So it will terminate and this won't run. However, if there was no return result, or say, for example, if it failed this conditional and got to here, and then it hit a return, it would escape the function. Yes, there is no curly brackets like in C#. So the question was, how is an end of function statement identified? And there is no curly brackets like in C#. That's very true, and that's actually a very good point. So there is no brackets like in C#. Let's go all the way back. So as you can see here, it's actually separated by white space. So x equals 5. This is not part of the function anymore because there is no, it's not tabbed. If it was tabbed, then it would be part of the function. But if there's no tab, then it's not part of the function. So say, for example, if I do something like this return statement is now not part of the define function, and this will return an error. It's kind of one of the things that makes Python a little confusing or hard to read, especially if you get into the weeds of it. Actually, I'm going to go ahead and stop sharing, and I'll share something else really quickly. Let's go ahead and put that here. Close that. And so here's one of my projects. This is called TurboASAP. It's several thousand lines of code. And as you can see, it can get very nuanced in terms of code, and that's because everything is separated by tabs. This is a continuation of one line, but everything is separated by tabs, such as your for loops, your try-catch statements, which in Python are try-except statements. There are no parentheses. They're separated by tabs as well as colons. So that could be particularly confusing, especially if you're not used to this kind of code block separation yet. So there's that. So back to here, everything is separated by tabs, and we can go ahead and define functions this way. Now, why functions are important? Well, it can essentially, one, condense code, especially if you have to do conversions all the time, instead of having to write, if this was multi-line, let's say result plus 5 equals 5, even though this is not necessarily correct. Fahrenheit to Celsius, 80, Celsius is not correct because, why are we adding 5 to this result? But as you can see here, from 26, it became 31. But what if I wanted to do this multiple times for different numbers? We are essentially saving like one line of code. And if this was many, many, many lines of code, we'd be saving many lines of code performing this function. So that's one thing. The other thing is that functions can call other functions. And functions can also call itself through recursion, but that's outside of the scope of this bootcamp. But essentially, you can go ahead and define functions using this notation, and there's a helpful thing to show you which is which. So the return statement, your parameter names, the name of your function, etc. And so when we go ahead and run our function, there was already an output here, but it's essentially just wanting you to do something like this. So Fahrenheit to Celsius of 32. Oh, we should delete +5. So let's rerun this code. As we know, code can be done out of order. Now we redefined it to the correct Fahrenheit to Celsius, and now it's 0. And then we can use it to do something like that. Now, like I said before, if you want to do anything useful with whatever this evaluates to, so this evaluates to 0, you should assign it to a variable. However, if you didn't have any return statement up here, nothing will be assigned because your return statement is what the function evaluates to. So if there was no return statement, what you're evaluating to this is actually a none type. So N-O-N-E, and that's essentially like an empty or null variable. So we had another activity here, which was to write a function turning Fahrenheit to Celsius. That's actually pretty easy. What's nice is that if we already had a temperature in Celsius, you can go ahead and just add 273.15. Additionally, you can go ahead and compose functions together. So for here, we want Fahrenheit to Kelvin. We had Celsius to Kelvin, and we had Fahrenheit to Celsius. How do we go from Fahrenheit to Kelvin? Well, you can go ahead and just use the functions that you already had. So temperature the temperature in Celsius is the Fahrenheit to Celsius of temperature in Fahrenheit, and then you call whatever temperature you had in Fahrenheit. This entire function evaluates to the conversion of Celsius, so it gets assigned to temperature Celsius. And then you call Celsius to Kelvin, the function we defined up here. Celsius to Kelvin of temperature at Celsius, this evaluates to the temperature Kelvin, which is temperature plus 273.15. This gets assigned to temperature Kelvin, and then you just return temperature at Kelvin. So we essentially used old functions that we've defined together in order to go from Fahrenheit to Kelvin without having to rewrite everything, which includes putting this in as well as putting this in as well. So when we run this, we should go ahead and run this first. Again, things can be run out of order. Celsius to Kelvin was not defined, as you can see here. because I didn't run this code block. Now when we run this code block, it evaluates just fine because Celsius 2 Kelvin is now defined. Then here's just another example of using our Fahrenheit to Kelvin outside of this code block. And as you can see, 32 Fahrenheit is 273.15 Kelvin. So that's the gist of functions. That was a very brief overview of what functions are. Now let's get into loops, which are pretty important. So loops are a means to run a specific pieces of code multiple times. So before, and let's go add a code block really quickly here. If I say if I had x equals 0 and I want to add 5 to this variable 5 times, I could do x plus equals 5. And go ahead and just copy and paste this. Oops. Paste this 5 times, and when we print x, it'll be 25. But that is not great, especially if you want to do it 1,000 times. You don't want to be pasting 1,000 lines of code. So instead of doing that, what you can do with a for loop is you can do something like for, let's say whatever. It could be underscore, which means an empty variable, but let's not do that. For I in range of 5, x plus equals 5. And when we print x, it also evaluates 25. So this line of code ran 5 times and evaluated 25. You can add more lines of code here. If I did print x here, this will evaluate to every time this code block runs, it actually prints out x as well. So the first time it added 5, printed 5, then printed 10, then printed 15, so on and so forth. So here we have letters and a string. What's important to note in Python is that there are several different ways for loops to be defined. In other programming languages, like let's say Java or C#, you have for, then you have to instantiate the for loop using some variable, its starting position, and then its ending position. So let's say the length of the list -1, and then the actual iteration step. So I++, curly brackets, and there's your standard for loop in other programming languages. Now, the problem is that in Python, this is very, very rarely used. There is a notation to get that kind of, the same kind of syntax, and it's using the range function. So for I in range of your starting step, your ending step, and your ending step, and the amount of times you want to iterate on that variable. So I++ equates to I plus equals 1, so 1. And then this will go ahead and iterate for you. And it's the same notation of start and how many times you want to step. However, it's much more common for you to see in Python shorthand versions of a for loop. So for example, here I have a string called named letters, and it has this value. I can say for letter in letters, and I can go ahead and print letter. And it will just go ahead and for every time it iterates through this iterable, so this string can be thought of as an iterable in the sense that it is a list that may look like this, right? And I can continue to write out the characters of this. think of it as the for loop going through every single object within this quote unquote list. It's really just a string, going through each and every element in this string and then printing out whatever value it comes up with that particular object. So if I do for letter in letter, the first time it runs, letter has hit the object or the string A, character A. And so letter is actually A. Next time it runs, so the next time this for loop runs, it prints out space. The next time it runs, it prints out S, so on and so forth. So it keeps going through every object within this iterable. Now, as you can see, it printed everything out sequentially. And just to really drive home the point, we can go ahead and print 1. And as you can see, it printed 1 and then printed tab. This is a tab character, and then A, then 1, then tab character, and then space, so on and so forth. So here, it is an example of actually doing calculations on like specific variables, such as, like, say, for example, we had a list of Fahrenheit temperatures, and we wanted to convert Fahrenheit temperatures to Celsius. Well, how would we do that? We can go ahead and say that for every temperature is the variable name of each and every object that will hold. For temperature in temperatures in Fahrenheit, which is this list, convert Fahrenheit to Celsius. Now, this doesn't do anything, right? So if we go ahead and print temps in Fahrenheit, it's still the same. It's not, it didn't change the actual values of the temperatures within temperatures to Fahrenheit, even though we called this function. And as many of you know already, it's because we're not assigning it to anything. We're not adding it anywhere. We don't have a variable to hold all of these, converted values. This is the wrong way to hold this value because X will be rewritten constantly. So what we have to do is essentially define another list to hold all of the converted values. So let's say, for example, we can say temps in Celsius, and we'll make it an empty list. And then, as I've shown you a while ago, you can go ahead and append temperatures, or you can go ahead and append objects to a list, such as this empty list, using the append function. So temps in Celsius, dot append, and we can append all of these converted Fahrenheit values to this new list. When we print this new list, as you can see now, we get a new list containing all of the previous Fahrenheit values to Celsius values. For people who understand programming, there is also something called list generators. And this is something I'll get into very quickly as it's slightly out of the scope of this tutorial. But essentially, because of this kind of like for loop syntax, code could be even further simplified depending on what you need or if you're building a list. So for temps in Celsius, I'm going to go ahead and comment that out and rerun this. So as you can see, we have an empty output. We can say temps in Celsius is Fahrenheit to Celsius. Temperature, for temperature in temperatures in Fahrenheit. And what we'll do, and this is called list comprehension or list generation, you can essentially put a for loop and whatever this variable evaluates to, it will append it or add it to the list. So for every temp in Fahrenheit, it will append this to this list. So now when we print temps and Celsius, as you can see, it did the exact same thing. Not only that, but because of this syntax, you can actually even put if statements here. So say, for example, I could do Fahrenheit to Celsius temp for temps in Fahrenheit if temperature is equals to 32. Go ahead and run this, and now I have a for loop statement and a conditional in my list generation. And now I condensed maybe a few lines of code to one line of code. And so if the temperature was 32, it did 32, and it only generated the temperature value for 32. If I had another 32 here, then I'd have 2. But that's something cool that you can do in Python and why this kind of syntax exists. So let's go ahead and go back. And let's uncomment these. So now we have an activity where we loop over a list. And as I've explained before, running the above loop without doing the append, nothing happens. And that was because we needed to append it to a new list to store the variables. And now here we have an example of temperatures. And here we're essentially just going ahead and getting your temps in Fahrenheit, temps in Celsius, and then going ahead and just putting the converted temperatures into Celsius. The fairly long way to do this. It would make sense for demonstration purposes and understandability purposes. It makes sense to do something like this and round it. And then here we're just printing out temps in Celsius at j from index 3, ending at 6, then at 5, and then printing out the actual list itself. So here we just talk about how we can essentially clean up many of the results using the round function. And so round for here, for example, if I did something like this and printed temps in Celsius, we have these very ugly numbers that are truncated after several characters. What we can do is essentially call the round function. And if you call the round function with only one parameter, it will, the pound round, let's go ahead and do that. We'll round the actual values itself. There we go. If you call round with only one parameter, it will round to the nearest whole number. However, you can define how many decimals you want by adding another parameter that's an integer, and you can continue to build things like this. So this evaluated to 0.0, but this evaluated to 3.89, so on and so forth. So you can clean the returns that you have using the round function. Now, one of the most powerful things that Python has at its disposal, much like any other programming language, is libraries. What's particularly important about Python's libraries, though, is that there are a lot of them for many different use cases. In fact, I believe for data science, Python has one of the largest library bases for data science purposes. So Python has to its disposal something called pandas, which is able to read and manipulate tabular or spreadsheet-like data, or any multi-dimensional data type. So one thing that people need to know is that I'm going to stop sharing the Jupyter Notebook, and I'm going to go ahead and share another Anaconda prompt. So let me go ahead and just run that. So here I have a blank Anaconda PowerShell prompt. And in this blank Anaconda PowerShell prompt, I can essentially install Python packages into my Python interpreter. Now, for most people, I'd recommend creating an environment, but for the purposes of this, I'm not going to show you how to create a Python environment. I essentially activated my general Python environment. You didn't need to know what I did, but if you wanted to install some kind of Python library, you can essentially call the pip install library name in your Anaconda prompt, and it will go ahead and try to install that library. So say, for example, if you didn't have pandas already, you do pandas install or pip install pandas. As you can see, I already have pandas installed. But if you didn't have it installed, it'll ask you, are you sure you want to install pandas? And then it will go ahead and install pandas for you. Going back. So now we're going to be using pandas to work with spreadsheet, quote unquote, like data. So for importing any library within Python, you essentially just call the import function and then your library name. So for us, we just want to import pandas. Go ahead and run that. And then if there's functions within these libraries, you can essentially call functions such as pandas dot read CSV. And so you can put a file here, and then it will go ahead and read a CSV. Additionally, some code that you might see in Python will import just specific parts of the library. So say, for example, if I didn't want to import the entire library, just specific things within the library, let's say for Keras, I don't know if this is necessarily the right syntax, but let's say from Keras models, import sequential. So now we're not importing the entirety of Keras, we're importing just the sequential model. And we can do the same thing for pandas. Now, another thing you can do is actually set a name for the library you're importing. So many people like to import pandas as PD, and so that later on, instead of saying pandas.readCSV or something, CSV, you can just write pd.readCSV, and it saves some key types, or key presses rather. Let's stick to the default name. And through here, we're going to be importing another library called glob. The reason why we're importing glob is because for this scenario, we'd like to now load file. So glob is a library that allows you to actually see files within a given directory. It comes from another, I believe this syntax or this name was coined in another programming language or some kind of like Linux, Unix thing. But essentially, through glob, we can import glob, and then we can call the glob function to check every single file within our current directory that has a CSV ending name. And then the star is a wildcard. So anything that matches .csv, we can go ahead and include it in our glob. So this returns to your list. And as you can see, if we go stop share, and I'm going to share my entire screen. And the reason why I haven't been sharing my entire screen is because my screen is very wide. And so it may be small to see. But if you go open up Python Bootcamp, and I'll just go extra large icons. Ooh, it didn't actually change the size of the text. But as you can see, we have 4 CSV files. We have Iris setosa all the way to missing Iris virginica. And in here, we have Iris setosa all the way to missing Iris virginica. So let's do that again. So glob is a means that we can actually find any file within our current working directory. For us, it's the Python Bootcamp folder. If I did something like this, then it would show every single file within the current directory. So any file name and any extension. But we don't want that. We just want the CSV file. And so now, as you can see, we have access to the file names of every CSV file within the folder. And now we can go ahead and load them into pandas. What's important to note about pandas is that there are things called series and things called data frames. So series can be columns. They can also be rows. When you add 2 series together, they become a data frame. Now, for regular programmers, you may think of this as just one-dimensional list, and then a data frame is a 2D list. But Pandas calls them series for 1D and then data frames for 2D. And so Pandas gives us a good or an easy way to actually load CSV files into a multi-dimensional or a 2D array without having to do it ourselves. It also can read Excel spreadsheets, which is not easy to do through Python's default open method. And so here we can see that we're essentially saying that let's define a new data frame as an empty data frame. And then for every file within CSV files, which is this list, go ahead and read the CSV, read the CSV, which is the file within CSV file. And then what we can do in Pandas is actually just select column headers. This is not actually being done here, but say, for example, if we had a column header like petal length, so this, and species, so this, we can go ahead and just get these 2 columns. The reason why we're doing this is because in the next line, we actually call the drop NA function to the data frame or this file's data frame. So what is drop NA? Drop NA is just to drop any row that has an empty or null value at that row. So say, for example, if petal length had an empty value, then we dropped it in, or like this entire thing had an empty value, then we drop this entire row because it's missing information. For us, what we're doing is we're calling the subset parameter, and we're setting the subset explicit parameter to be important columns. Our important columns is petal length and species. So what essentially that means is that in the petal length or the species columns, if you find a missing value, drop that entire row because it's missing information that's important to us. And then lastly, once it's finished doing all of this, we'll append the data frame, this file's data frame, to the original data frame. go ahead and run that. And as we can see, we are displaying the data frame, and we're sampling 4 items from the data frame. So it just sampled a random 4 rows from this data frame, and we called the display function. The reason why we're using Jupyter notebooks right now is because of pretty printing, such as this, where you can go ahead, and this is like dynamically generated. As you can see, the index numbers are changing. This is a dynamically generated table, something that you can't really print out into a standard out or something like that. So that's a nice function of doing your data analysis within Jupyter Notebook. So as you can see, you can go ahead and look at the species, and some of them are a little ugly. And so you can go ahead and clean this data up. You can also do drop-in-A to remove any missing information, clean data that way. And in here, we talk about how, say, for example, the only columns that you'd like is petal length and species. You can just select certain columns within data frames. So say, for example, we run this and we run df.columns. Now we only have the petal length and species columns within our data frame. The syntax for this is your data frame, and then it's much like a dictionary where you're trying to give it a key. And your keys for Pandas data frames are your headers. So say, for example, if I just wanted the column petal length, then I can just put petal length in here, and this will result to the data frame with only the column petal length, and all of these other columns go away. Now, if you wanted to do multiple columns, now you'd have to give it a list, which looks a little funky, but essentially results in something like this, where we could do species. We could also do something like sepal length. And so now we're giving it a list of keys. So a list of all of the columns that we care about, which is the exact same as this. So when we go ahead and display a sample of this, as you can see, it prints out a data frame with just the 2 columns in it. Now we talked about like selecting columns. Now let's talk about selecting rows. Selecting rows in Pandas data frames are done through the lock method. And so the location method will essentially allow you to select through an indices. You can also do it in this syntax where you have your row label, which will often be your indices, and your column label. So for here, for example, we're doing a conditional in addition to selecting rows. So say, for example, here our condition is that the species column is equals Iris virginica. And we can display this condition. So df at the location where the species is equals to iris.virginica, and then sample this subset of a data frame. So, this subset of a data frame. So when we do something like that, as you can see, now we're selecting at the rows where this condition exists. It's fairly similar to things like NumPy, if you know Python, NumPy broadcasting. And so, as you can see here, we have species, and then Iris virginica, and then it just gave us a bunch of rows where it met the conditional. So as we can see here, we can also select or run methods to whole columns or whole subset of the data frame. So for example, here we're calling the unique function in order to get all of the unique variables. We can also change all of the text within the species column to be lowered. So we lower all of the text or the strings, or we convert all of the strings to be lowercase characters within the strings. And that would clean up things like Iris virginica, which is capitalized weirdly. And then we can go ahead and modify only specific rows to have specific values. So say, for example, if we went into a species and it was Iris virginica in species, then you would change it to Iris virginica. And a nice thing about doing string lowering or string string uppering in quotation marks, is that you can make selection criteria much less picky. So you can convert all of your strings to uppercase and then just select on the uppercase string so that even if it's capitalized weirdly, this will still resolve in selecting this value because this is all converted into caps now through the string.upper method. So now when we run df species string lower and then sample 5, as you can see, our species are now lowercased in comparison to here, where Iris was uppercased. And then we can do a lot of cool things, such as like merging all of these together. So say, for example, if we wanted to multiply all of the Iris virginica values from inches to centimeters, we can go ahead and run a conditional and then run an arithmetic operation on the conditional. So for example here, and this may be a little hard to read, select the rows in which the data frame at lower in species, so column at species, is equals to Iris virginica. Then to petal length, multiply it by 2.54. So here we have our data frame. It checks first if this in species, the value is Iris virginica. Then in petal length, it will apply this arithmetic operation. As you can see, we have here Iris versus color, and we can see the Iris virginica is quite a bit larger. If we wanted to make this ridiculous, we can go ahead and do that. And now we can see that for sure, it's only affecting Iris virginica values, but not everything else. So we've introduced a lot of new things with pandas, including importing libraries such as pandas and glob, using glob to get all of the CSVs within our current working directory, creating a pandas data frame, and then essentially going through each file within our CSV files, which was created by our glob function, and then appending all of these files into a single data frame, as we can see here. Then from this concatenated data frame, we select the columns that we want. We essentially normalize, quote unquote, the species strings so that our conditional would work despite capitalization. And then we converted through the lock function, converted all Iris virginica petal lengths to inches from centimeters. And as you can see, this is what you get. The last thing I'd like to go through before we take a break is hypothesis testing. So as I said before, there are a ton of different libraries in order at your disposal for data science. And so, for example, you have things or libraries such as SciPy, and you can go ahead and run statistics on the data frames that you've created from pandas. So say, for example, dflock, Iris virginica, and then you also get Iris setosa, and then you can do a t-statistic between virginica and setosa and print these values. One thing in particular that that may throw you off is what is t comma p. This is multi-variable assignment. So t-test ind would give you a t-statistics as well as a p-value, so it returns two values. And what you're doing is essentially something similar to t equals this values, the first value or value at index 0, and this at 1. I know you can store this item into another variable, so you don't call this function twice, but this is just a prettier way of doing multi-variable assignment without having to write multiple lines for it. So here we print out the t-statistics for the values that we got from our data frames. So that's it for Python right now. I believe we're going to have a break from 11 to 12. We're ending a little early. Before I open the floor for question, after the break, what I'll be doing is doing some activities, including walking through this real-world example. And then we'll have another activities file where I'll just be running through the activities and running through how to do those activities. And then afterwards, I'll teach you guys how to install machine learning libraries. We'll be installing scikit-learn. And then next week, what I'll be teaching is just running through a project really quickly by creating a very simple machine learning, or I guess multiple machine learning models to detect languages. And we'll be doing that next week. So that's it for now. Are there any questions?
Yeah, Dr. Lee, this is really good talk.
Thank you.
Yeah, so I think the student may be very interested to run the Python for their own data. So could you introduce how to change your current working directory and try to import like their own data?
Oh, yes. So I didn't quite want to get into that, but it's actually kind of simple. So let me go ahead and share this really quickly. So to change your current working directory for Jupyter specifically, not for, you can do it many other ways, but for Jupyter, you'd essentially, for example, for us, here's my home directory. I go into Documents, Python Bootcamp. And so your working directory for a particular notebook is, your working directory is where your particular notebook is found. So this entire thing is your current working directory. As you can see, we have access to these folders such as assets, data, and ML. And so if I go into here, it'll run this notebook again. And then, as you can see, this is the working directory that I have. If I wanted to change my working directory, as in my home working directory, you can go ahead and just go into a folder and then create a new Python notebook at that directory. However, if you wanted to access a subdirectory, then you would go ahead and say, for example, let's go into glob. You would go ahead and let's copy this, paste this, and this will just be an example. If I wanted to access a subdirectory, I would go type the folder name first. So, for example, ML, and then slash. And then you can go ahead and access anything within ML. Ooh, is that actually empty? Oh, there are no files in here. So let's do this. Let's go create a file folder. I don't think it works for that. Let's save this as entitled. See if that's in there. Okay. Star. Okay. As we can see, now it created now we can see all the folders within a folder that's not within our working directory. And I believe if you can go outside of your working directory, so a directory up, by doing double dot, and it will go up one directory, and now you can see all of the files outside of our working directory. So if I go into Python Bootcamp, and then here's where my notebook was, I go one step outwards, and as you can see, run cval server.txt is there. And we do have run cval server text here. The thing about, so if you wanted to do it outside of Jupyter Notebook just changed where your notebook is. Outside of Jupyter Notebook, if you were in something like PowerShell or in your Anaconda prompt and you're running Python like this, and oops. If you're doing something like this, in order to change your working directory, exit, you would essentially change directory to wherever you need to be, and then run Python, or run your Python x.py, run your Python script. And then for IDEs, you essentially just change your working directory through your project. This is PyCharm, but you would essentially have to change it through your actual IDE itself.
Okay. Yeah, great. Thank you.
Yeah, no problem. So are there any other questions? So I see the question saying that, are we continuing the session now? I have the invite for the next session on August 13th. Dr. Liang, did you change that? So it was planned to have a session this afternoon,
yes,
a continuation of this,
1
and
to
then a
3.
session next week.
Yes.
The section from 1 to 3 is going to be short, mainly because we're just going to go ahead and go through activities to cement like basic concepts, such as, cleaning up lists or arithmetic. And then I'll be going over just general Python stuff, and then installing machine learning libraries so that next week we can make simple neural networks and stuff. So yeah, we have a session from 1 to 3, but it won't be as long as that.
Oh, Dex, do you, before we close, do you mind that you give a brief introduction about yourself, your achievements so far, so that the people know more about you?
Okay, so hello everybody. My name is Dax Ledesma. I am an undergraduate data scientist, or computer science major, data science concentration with a minor in biology. I am specifically focused in machine learning and neural network applications and the creation and innovation of neural networks within biology, specifically botany. Actually, it might be easier to just share my screen and go ahead and go to my Scholar page. So I have several papers or journal publications in terms of human motion generation, as you can see under Dr. Liang. But I also have publications within botany, such as Saxiferga dactylites, naturalization within the US, as well as my own projects, such as the creation of new neural networks to beat old neural networks within botanical purposes. So this was a creation of neural network that beat Microsoft's faster RCNN very handily, with over 30% more accuracy, whilst also being 8 times faster, or up to like 30 times faster, I believe. So I'm specifically focused on botanical neural network applications. Currently, my undergraduate thesis is focused to improving this work for a more widespread usage than just per barium sheet CRC detection. Additionally, I have a lot of experience doing AR and VR under Dr. Liang, as well as the creation of new neural networks for human motion generation. So here we were using machine learning as well as VR in this publication, and then in this preprint was a neural network that I created, I believe, 2 years ago, solving problems with an optimization of neural networks for human motion generation and small data, big task type data science problems. So if this would load, yeah. So it was the creation of a multi-pipeline, double correlated neural network for human or for phantom limb generation, or real-time phantom limb generation. Actually forgot we called it VHNN-AE2, which is not easy to remember. Don't worry, the other neural network is called ColorNet, which is a lot easier to remember. But yeah, I've been doing machine learning type tasks, very fortunately, thanks to Dr. Liang, basically the summer right after my freshman year. And then I just continued to work on it until today.
Okay, if you don't have any other question, just yeah, you can keep it in the afternoon and at 1 p.m. Yeah, we will just restart at 1 p.m.
Yep, and it should only take around an hour. So realistically, it's from 1 to 2.
Yeah, actually, I don't have invite for 1 p.m. Could you please share the Zoom link to me?
Yeah, Vicky, I will do that. Yeah, after we finish. Right now, I have to focus on the recording stuff.
Sure.
It's fine. I'm going to send it to Vicky. Yeah.
Is it the same link?
No, it's different.
It's not the same link. VG, if you'd like it now, I've sent it to you, and you can. You should be able to copy and paste that, I think.
Thank you.
No problem.
Don't worry.
Any other questions?
I'm going to email you, okay?
Sure.
Yeah, thanks. Okay, thank you for your great patience, and thank you, Dex. Yeah, great talk. So we will meet on the 1 p.m.
Cool. See you guys then.
Thank you. Very good talk. Yeah.
Bye.